On this video, I'll be explaining to you the three different phases or states of matter. So, as I said, matter can occupy three different states. The first state is the solid state. The second state, the liquid state. And the third state, the gaseous state. There's also a fourth state called plasma, but we won't be talking about that state in this video. Each of these states or phases look different and have certain characteristics that I'll explain now. So the first state is the solid state. I'm going to explain all three different states by using water, which, as you know, can be ice, liquid water we usually drink, and water vapor. So water as a solid is called ice. As you can see in the picture, ice has very relevant characteristics that are totally different from what liquids or gases usually look like. So one thing you should know about solids is that they are very tightly packed molecules. As you can see in the ice cubes, they're they're compressed into a solid state, which is what gives them a fixed shape. So if you put ice on a cup, it will not occupy the cup as water usually does. It will maintain its shape until it transforms into a liquid. So it has a fixed shape. Again, this is due to strongly packed molecules in the structure. The second state of matter is the liquid state. For the liquid state, we use liquid water that we have to drink daily. And well, as you can see in the picture, it is not as tightly packed as the solid was. And what's most important about liquids is that they can conform the shape of its container. So it will conform shape of container. Like you can see in the cup. But it will only conform it to the point of where its volume lets it. So it will not conform it to the top every time. So the more water you have, the more it will conform it, the less it will conform it. Now the last state of matter is the gaseous state of matter. This represents the gases, or for this case, water vapor. Gases are totally different from solids and liquids in the way that gas particles or molecules are not packed at all, so they are all over the place. This is called molecular randomness. Meaning that the water vapor has, or gases have, the highest molecular randomness of all three states, and the lowest would be the solid state. Another characteristic of gases would be that the particles conform the entire shape of the container. So it doesn't matter the volume of the gas you have, it will always occupy the whole container. So by having a flask covering the top, the gas particles will be everywhere. Doesn't matter how many particles you have, they will always be scattered around. That is because of how high their molecular randomness is. So to review everything again, I found some pictures that are found really helpful. So well, as you can see, for the solid state, the container would be the cube, and the blue cube would be the solid object. It will always hold its shape. It will not conform the container because of its fixed volume. You can see that how tightly packed the molecules are. These are water molecules, and they are not letting go. For the liquid state, it is conforming through the container to the point of what its volume lets it. So this amount of water lets it just get there, and it has a fixed volume too. And you can see that the the molecules are still somehow packed, but not as strongly packed as the solids. And for the last one, you can see the gas molecules everywhere, or on the flask, everywhere. And they take the shape of the whole container, as you can see in the cube. So that is because of its high molecular randomness. And those are the three phases of matter.